Thank you everyone for joining this presentation today. My name is Mattia Fazzini and I'm an assistant professor at the University of Minnesota. Today I will present our new idea on how to automate test mocking for mobile apps. Now, I'm pretty sure almost everybody attending this presentation uses mobile apps in their daily lives. In fact, you can use mobile apps for reading the news, doing online shopping, streaming content, and nowadays even attending research conferences. Because some of these apps are used daily by millions of users, it is fundamental to thoroughly assess their quality and avoid failures due to undetected bugs. To reveal these bugs, we can use testing, as this technique has been shown to be very effective in finding bugs. However, effectively testing these apps shows to be a complex task, as these apps typically have a large number of interactions with the software environment. Specifically, tests that involve interaction with the software environment might suffer from flakiness, require a long time to complete, and might be affected by interference bugs. A common strategy to mitigate these kind of issues is to replace the part of the environment used by the app with a model of the environment. And developers usually do this by manually creating test mocks. Unfortunately, creating test mocks manually is typically a time-consuming and error-prone task, and these mocks cannot generally be reused across tests. To address the issues I just mentioned, in this work we propose a framework called MOKA. The key intuition behind MOKA is to leverage the fact that the framework, or the environment code, is already implemented, and use this information in the creation of the mocks. At a high level, the framework takes as inputs the app under test and its test suite, and operates in two phases. First, MOKA collects mock data from the test executions. Then, in its second phase, MOKA generates test mocks from the data using program synthesis, and refines the mocks by repeating the synthesis task while incrementally considering new mock data. The final output of the framework is a set of reusable test mocks. We call these mocks reusable as they can also be used with updated or even newly created tests. Additionally, these mocks can also be used for tests of different apps. Let me now give you some details on how the two phases of the framework work. In the mock data collection phase, which is the first phase of our framework, MOKA runs the test suite on the app under test and collects some data at the points where the app interacts with the software environment. In our work, we call these points interaction points. Every time that a test exercises an interaction point, MOKA collects information about the software entity that needs to be mocked, the input and output flowing through the entity, the statements of the software environment exercised by the test, and the coverage of the test. After collecting mock data from all test executions, MOKA starts generating test mocks. In this process, MOKA first groups mock data based on the entity that we want to mock. We do this to generate a general mock that can be used at the different location where the mock entity is used by the app and its test code. Then, for each group, we use the mock input and output data to synthesize a mock. Specifically, in this task, we use component-based program synthesis. Our instantiation of component-based program synthesis has three characteristics. First, the database of components used by the synthesis task is the one collected in the first phase of the technique. Second, we synthesize a program for the mock whose size is less or equal to the size of entity being mocked. And finally, we constrain composition of STA nodes to composition that are already part of the mocked entity. If the synthesis task is successful, we have a test mock for our app. At this point, we try to further generalize the mock by generating new mock data. Here, we use two techniques. First, we use input generation based on concurrent execution, and our goal is to find one input that increases coverage. Second, we use mock data collected by running the test of other apps on the apps. When we have new mock data, we repeat the synthesis process. And when the synthesis process is successful, we update the mock. Otherwise, we terminate and return the previously generated mock. If the synthesis process is not successful in its first iteration, we generate a mock based on the more general concept of record and replay. To assess the potential usefulness of our framework, we conducted a preliminary study in which we investigated how developers use test mocks when testing their apps. In the study, we analyzed the test of the apps that are both on F-Droid and GitHub, and we found more than 1,000 of such apps. We first looked at how many apps have tested, and we found that 20% of the apps have tested, and the total number of tests is above 11,000. This number gives us some initial evidence that it's possible to use tests of other apps to generate test mocks. Second, we studied 20 apps to find how many developer-created test mocks model the software environment. We found that 30% of the test mock model the Android framework. If we also count third-party libraries, this number goes to 41%. This result provides initial evidence that MOKA has the potential to significantly help developers if the framework is able to generate test mocks. As future work, we plan to implement MOKA for Android apps and evaluate the framework on real-world apps. In the evaluation, we will evaluate reuse of test mocks across versions and with new tests. Finally, we will also evaluate the time savings offered by the mocks. In summary, I've presented that testing mobile apps is a challenging task because these apps frequently interact with the software environment. Developers end up creating mocks manually, but this task is time-consuming and error-prone. Finally, I presented our framework for creating these mocks automatically and detailed a study which shows the potential usefulness of MOKA. This summary concludes my presentation, and I'm happy to take questions.